Hey guys, I'm here with Omar. He's this year's project manager for the CSUN FSAE competition, essentially.
Yes.
He's going to give us a quick tour of the lab and show us kind of the improvements that they've made from a lean perspective, and also see some of our products in action. Let's get started. So you are a senior. Most of the people on this team are seniors, right?
Yes.
Okay, and some juniors volunteering?
So how CSUN works is that most competitive teams now have this project as a club.
Okay.
But CSUN's kind of special in the sense that they kept that as a capstone project for senior design.
Okay.
And so we do work with the 25 team members, all mechanical engineers. But about 2 years ago, they did make it into a club, so we could reach out to juniors, freshmen, and sophomores.
Oh, that's cool. Okay.
To actually help them. A lot of people grab this as like hobbies.
Yeah, yeah.
But they also want to learn and get the hands-on experience.
So they can level up also over the years. That's awesome. Well, you guys always finish like at least on average, maybe top 10-ish?
Yeah, we recently it's about top 15.
Yeah.
But we are improving just because COVID.
Yeah.
It was very difficult to pass on the knowledge. It really hurt many teams.
I think that's amazing because the competition, it has literally how many schools? Like
it has officially 146.
I was gonna say
that do register. But about 120 do compete or go to competition.
So to be in the top like 10, 15 is like,
yes,
it's a huge deal.
And so one thing is that it is international. So we do see teams from Germany, we see teams from Mexico, Portugal, Poland. They all come around the world to compete.
Yeah.
And then of course there's other competitions in Europe and stuff like that.
That's amazing. Cool. So what do we got here? I see lots of 3D printed things. So that's pretty cool.
Yes, so one step or one phase of how we work in CSUN is that we do have a preliminary phase. And so we do create a mock-up. It's almost a 1-to-1 scale. And so we will actually start using 3D printing, and this is kind of recent.
Okay.
And we'll print out the nodes and use PVC pipes to start understanding what space we're working with within the chassis.
Yeah, I love it.
And so through this, we'll make a mock-up design of the seat jig, and we'll get our potential drivers in here, and we'll start seeing what we could optimize within the chassis.
Yeah, I love it. Yeah, I've said often that everything works in CAD, but things don't work in the real world as expected. Or they may look good, but they're the wrong size. Yeah. It's interesting if you had a really big driver.
And so we do some type of lean manufacturing in here. If you go through this room.
Yeah, let's go.
And so we do have sections here.
Yeah.
It works. So we have the 3D printing, so we're not walking back and forth from outside.
Yeah.
And this is our 3D printing station. And then if there is any PVC pipes that we're cutting, we do have our mechanical or milling manual machines.
Yeah, kind of your plastic fabrication type stuff. That's cool.
And then we have a table here in the center to see if you want to bring in different parts from a 3D printing. If you're bringing parts here, you'll work on this table and then take the whole assembly into the mock-up.
That's a really good approach. So that would be, you're minimizing the waste of motion, because if you had a table over there and everything was here, you'd be walking back and forth. It's crazy. You just put it in the middle. Yeah, and then things along the wall. I love it. Yeah. That's fantastic. Great. And it hasn't always been like this, right?
No.
Okay.
So this was changed last year. We finally were able to get this room. And so they went to your tour 2 years ago or 1 year ago. And they decided to implement lean manufacturing like this.
Wow, that's awesome.
Yes.
Very impressive. I love it.
And so our next space or area, we have CNC machines. So a little bit about CSUN is they're one of the few schools that still manufacture about 80 to 90% of their parts. And so we do get sponsored by Haas, as you guys could see.
Yeah.
But again, it's the same thing, lean manufacturing. So we have all the machines around, and once the parts come out, we put them on these extra tables, and members will start grabbing parts and start going to the assembly room.
So what most people don't know, well, I would say CSUN isn't a big name as far as universities. It doesn't, headlines aren't written, but those of us in manufacturing should know, because this is where Gene Haas, founder of Haas Automation, graduated from. It's his alma mater, which is pretty cool. You know, so that's the claim to fame for CSUN in manufacturing world. So
yes,
yeah, very cool.
So we do have toolboxes around, and like in your tour, we did create little 3D printed to create or separate the different end mills.
Right, I love that.
Tapping drills.
After our most recent tour,
yes,
that's awesome. That's
and
great.
so we do have labels that tell you that we have tap drills, and we even got
I love it.
The foam.
So how long did this take? Like, I know how long 3D printing takes, but you had to like get multiple people together to say, okay, we got to just do this.
Yes. So it took about, I want to say about 3 weeks.
Okay.
Just because of the 3D printing time and stuff like that. But honestly, it didn't take that long.
Okay. So beside the time it takes to 3D print, like if you could snap your fingers and have one of these organizers, would it have taken like maybe 2 weeks, 1 week?
Yeah.
And these are students that this is their part-time kind of job, right?
Yes.
Okay, so I'm just trying to think if a shop did this just every morning for maybe 20, 30 minutes for just a short period of time, they could make little improvements and change one massive work area, right?
Yes.
Yeah, okay.
Yes.
Yeah.
So that's what we try to do. And then if you guys walk over here.
Yeah. Oh yeah, nice.
So we do have our calendar, and so every time somebody walks out, they know what's coming up.
Yeah, there you go.
That way, as a visual representation, when they're done here, they could start preparing for the next day.
I love it.
And they know what deadlines they have to meet, fundraisers, meetings, and all that thing.
That's awesome.
Yeah.
I love
Especially
it.
because we're students. Sometimes they don't come into the lab as often as we would like.
Yeah.
But once they start leaving the Haas Lab, they could look and get all their deadlines.
Good visual. Yeah, I love it. I love everything. So you guys got a VF4 SS. That's pretty awesome.
Yes.
Big tool changer. You got a TR something, TR160 maybe. That's a 5-axis. And then I noticed,
think so, yes.
Noticed over here, you guys got our pallet system.
Yes, thankfully your pallets come in handy.
Yeah.
And so we do use them. We do have some pallets that have been used over there.
Yeah. So this is cool because most people don't realize, like normally you would have a vise and you would just attach it to the table, period.
Yes.
But you attached it to pallets because you are one of the few schools that still makes all your parts.
Yes.
You need to change over. Like the setup would crush you if you had to be doing that. So you've palletized everything. And I just want to say you're doing everything right. That's awesome. I love it.
Thank you.
Yeah.
But yeah, that's one of the.
That's how you get in the top 10%, you know? So.
We try as best as we can.
Yeah, cool. And then you have a ST20.
Yes, an ST20.
Yeah, that's cool. Can I peek inside? Can I open it?
Yeah.
Yeah, nice. Cool. Pretty straightforward.
Yeah, so we do have a different chuck, which is bigger than what we have. It should be down here, but I think we are in the process of getting a new one or such. Yeah. So we would change this out when we create bigger parts like the restrictor and things like that.
Oh, sure. Yeah, nice.
And so we do have sample pieces up there to display.
Yeah.
So how the manufacturing works is that we do 3D print it first, see if there's any defects.
Yeah.
And then we'll start manufacturing just because we're very short on time.
That's the best part of 3D printing.
Yeah.
You make the part once because you've tested the geometry. Yeah.
Yes.
I love it. Yeah.
And so just because we're short on time and we're students, we do make mistakes.
Of course.
And so that's how we try to minimize those errors.
Yeah.
And that time efficiency.
Yeah. Well, just so you know, when you become an actual engineer, you'll never make mistakes again. That goes away.
Hopefully. We have our aerodynamics spot.
Yeah.
And so, fortunately, we're still like in the design phase, the preliminary phase. Yeah. So this is where Aero will start working. Yeah. Of course, we have the computers, and this is literally where they do all their research, all their high-level sims. And so the one with the blue hat is Andrew, and he's our Aero lead.
Okay, got it.
And so we try to implement lean manufacturing in thinking of manufacturing. That's why we have an open space in the middle. And if when we start manufacturing, the tables are in a circle. Yeah. So you could work at different spots whenever you can. And the computers, all you would do is put them under the table so they won't get in the way.
Nailed it. Yeah.
Yes.
So talk to me about the timeline. This is like the new race team for this year.
Yes.
Are we in October? We're in October. And then the car is due when?
The car is a drivable car. I am planning to have it at least in the beginning of January.
Wow, okay. Yeah.
Probably February. A little bit optimized, kind of optimistic on that sense.
Yeah, sure.
But I do believe my team can make it.
Very cool.
Then we are thinking of doing manufacturing, at least starting around late November, early December.
So you're close, yeah.
Yes.
Wow.
So
okay.
we're already in the prepping phase.
Yeah. And then the competition?
The competition is in May.
May.
So I am trying to go for at least about 2 months of testing.
Yeah.
Because that's the most important part of building a race car.
Very cool.
Here we have the engine area and the controls area. So again, lean manufacturing, we have the tables in a circle surrounding the car. So when we start doing dyno days and start building engines and testing our engine, they could literally put the monitors under the tables and start building or using the space to optimize.
Yeah, that's really cool. Yeah, you're the thing that I mentioned to you guys on the tour is you don't want to have to like work in the environment. The environment should work for you.
Yes.
So by going mobile, and yeah, it's not on wheels, that's fine, but you can easily move it, 2 dudes moving it. It doesn't have to move for another few weeks or a month.
Yeah, my goal was that we're not moving too far. Because then engines are really heavy, the car is really big.
Yeah.
And so we're trying to minimize how much movement we're doing. And just because we're a school, there's sometimes you can't have like resources as like a moving table sometimes. And so we sometimes work with what they give us and try to optimize that space.
That's great. This may be before your time, but this I don't remember was always here. The dyno,
No.
I feel it was over here, wasn't it?
So when I started volunteering, it was shifted this way horizontally or across here.
Okay.
But we recently moved it to actually have, so that table with the rolling wheels, you would move it in front or close to the driver so they could see when they're tuning and they see the graphs on a bigger screen.
Yeah, got it. Really
so we were able to get a table with moving tires.
Yeah, nice.
To be able to move and optimize.
Really cool.
Yes.
Yeah. So one thing that most people don't recognize, you guys are limited, you have lots of limitations, time, budget, people power, that type of thing. So like me, if I'm at the company and we're like, we need a rolling table, we just go buy it, or we just make it. But you guys have to really get strategic about every change you make around here.
Yes.
Yeah,
yes.
Wow.
Especially because we're sharing with other senior designs.
Right.
We can't invade their space, and, like vice versa with us.
Yeah.
And so it's very difficult when it comes to planning out the space.
Yeah.
But again, we do try to make it work as much as we can. That way, that's why we started putting the dyno this way.
Right.
So
it's out of the way. Yeah, I love it. Cool. Can we look at the car up close? All right.